Okay, so on, I guess it was Thursday, wasn't it? We didn't have to pull Friday. On Thursday, this is what we talked about. We talked about our numerator, if it had a higher degree, where you were going to have an oblique asymptote. Specifically, if the degree was one higher, it would be a slant asymptote, just one of them. Okay. We talked about how we needed to use long division or synthetic division, division of some sort, to divide your numerator and denominator to find the slant asymptote. That was your homework over the weekend that some of you probably did last night, which is fine. Minus the remainder. Okay? How many of you waited till last night to do your homework? That's not as many as I thought. Good job. Okay. So this is the example that we started with. Do you have this in your notes somewhere? Okay. And if you don't have room to make the graph in your notes, like label it example 1 and then like put your graph for example 1, later. But we're going to go ahead and go through the graphing of this. Okay? So I'll just remind you, we went ahead and we factored it, but we couldn't cancel anything out. We identified our vertical asymptote to be x equals -1, since that's where our denominator was 0. We went through the division of numerator divided by denominator to get y equals x minus 2 for our slant asymptote. Okay, now we need to graph it. Okay, let's start with the vertical asymptote at -1. Our process for graphing these really isn't going to change. The only thing we have to worry about is that slant asymptote, which is why I had you kind of practice what you did for your problem of the day. Y equals x minus 2. That is a line. What's our y-intercept? -2. Okay, and we have a slope of 1. So you can get out an idea of some sort and use it as a straight edge. I have rulers if you want to use rulers, or if you just want to make it so that we have a slope of 1. There's our slant asymptote. So it's going to be a little bit different graphing. Like I said, if you want to use some sort of a straight edge to make sure you're getting it with the correct slope, that's fine. Okay, I kind of use the tick marks or like my grid system, right? I knew that I needed to go through each of these coordinates, so I just made a tick, like a little dash through those coordinates that I knew it needed to go through. Okay, at this point we have to graph our coordinates. Okay, and this is kind of where things look a little crazy. Okay, but we know that our behavior has to approach the asymptote, okay? So even if you think that your coordinates look kind of wonky, they might in a slant asymptote problem, okay? So if our vertical asymptote is at -1, I'm going to ask you to do the same thing. Pick two coordinates to the right, 0 and 1. What happens when we plug in 0? We get 0. What happens when we plug in 1?
0.
We get 0. Okay, so you're like panicking. My coordinates are next to each other. It's really okay. Okay. What?
That was fun.
Do you hear the panic in my voice? Okay, we know that we are going to have to approach the asymptotes, and so you just got to make a little turn in between those two coordinates, but it's fine. That could happen. Just make sure you approach your asymptotes. Okay. All right. Since our asymptote is at x equals -1, we would need to choose -2 and -3 to plug in. Okay, so help me out. -2 squared minus -2 over -2 plus 1. Is that -6? Yeah, because you get 4 minus -2 is 6 over -2 plus 1 is -1. Are you convinced? Okay. -3 squared is minus -3, 12. Then we have -3 plus 1 would be -2, so we get -6 again. Probably some symmetry here is a good thing, right? Okay. Here is the good news. I will never ask you to identify the range of a rational that has a slant asymptote. Okay? There's no way for us to actually know what that range is. We don't know where that little turn is without calculus, and so I'm just not going to ask you for the range. Okay? We know our domain is everything except the asymptote. Sweet. So we'll just keep it like that. Okay? Now, I will warn you that when you have a slant asymptote, one of two things will happen. You could get your curves to be nice and skinny, or it is possible that you could get them to be opposite here, like where it's really big and wide. Okay? So when you choose your coordinates, we're really not sure if they're going to be in between in the smaller or the bigger part of our graph. When you plug in, you obviously will figure that out. Okay. Questions? Let's go to our second example. You should have this work on your page somewhere. Okay. Now what we did here is we factored an x out first, because we had, they both had an x in common. We crossed it out. So we have a hole at x equals 0. We identified then our vertical asymptote to be at -2. We performed our division with our simplified version to get y equals x plus 2. So go ahead and take some time for me and graph those two asymptotes, please. Because x plus 2 is in our denominator. And so, and -2 would make our denominator 0. Okay, so I'm going to make our XY chart on the board, and then I'll just talk and plot the coordinates over here. Okay? Are you ready? Okay. Gabe, to the right of our vertical asymptote, what two coordinates should we pick? -1 and 0. Are we plugging into the simplified or the original? Always go into the simplified, okay? So if we plug in -1, we would get 1 minus 4 plus 3 over -1 plus 2. What is that? 0. Okay. 0. What happens when we plug in 0? We get 3/2, right? Now, what's happening at 0? We have a hole. So at 0, 3/2, we have a hole. And then we know we have to approach those asymptotes. Okay, so here's one where it's in the wider part. All right, on the other side of our asymptote, we can plug in -3 and -4. What do we get when we plug in -3? Do we get 0 again? Yeah. Nice. Okay. What about when we plug in -4? Would we get -3/2? Yep. Okay, and that's all that's you. So what I'm going to do, I'm going to give you about 10 minutes to get what you can done on the front side. Your homework is to finish the front side and do all of the back. But at about 8:35, I'm going to transition to something that deals with what was a struggle on our quiz. Okay? So I'm going to give you about 10 minutes to work on some of those slant asymptotes. Maybe you could even finish the front side and only have the back side for homework. That would be cool.